When we breathe in, oxygen enters our lungs. Once it's in our lungs, it diffuses through these small single-celled sacs in our lungs called alveoli. It diffuses over into our bloodstream. This process of gas exchange is regulated by a concentration gradient. So the oxygen is going to move from an area of high concentration in our lungs to an area of low concentration in our bloodstream. Once it is in our bloodstream, it binds to hemoglobin molecules, which are little molecules that are free-flowing through our bloodstream. They are basically the transporters of our oxygen molecules. They get them where they need to go. And it's going to bind to this hemoglobin molecule and transform it from being T state, which is deoxygenated hemoglobin, to R state, which is oxygenated hemoglobin. This process is explained in the Perutz equation, where the addition of oxygen from the lungs shifts the equilibrium to the right, which is in the direction of the R state. So now we have a bunch of oxygenated hemoglobin molecules. Those molecules are going to leave the part of the bloodstream by your lungs, and they're going to travel down to your distal tissues or skeletal muscles, wherever it wants to go, and that does it through the arteries. So oxygenated blood is carried through the arteries. Once it reaches its target tissue, it's going to unload this oxygen onto myoglobin, which is bound within the tissues. It's not free-flowing like hemoglobin is, and it has a higher affinity for oxygen than hemoglobin does. So myoglobin takes those hemoglobins, it's in the tissues of your body, and it's going to use that oxygen as part of fuel consumption. So what that is your body takes fuel that it's been given and it combines it with oxygen, and you create energy, and you also create water and a waste product, CO2. So the energy generated during this fuel consumption is in the form of ATP. That is the currency that our body uses to get everything done, and it allows us to do all of the daily movements we do. So me shaking my head as I talk or talking with my hands, I need energy, which is ATP for humans, to do that. For a lot of people, this is important because when you exercise, or like I like to lift weights, you use ATP to have the energy to do that and to do it effectively. So when we're exercising, so pretend you're at the gym or during your game, if you play a sport, our muscles take ATP, they hydrolyze it, so they combine it with water. They extract from it the 30.5 kilojoules per mole of like really important energy that they need, and they also generate protons, so hydrogen ions, along with ADP. But the important thing here are the hydrogen ions. So those protons actually contribute to the oxygenation and deoxygenation of hemoglobin through metabolic acidosis. What it does is it just makes the process of transitioning to and from T and R state more efficient. So another important thing that I brought up earlier is that when you are going through fuel consumption, you create a waste product called CO2. And our bodies can't just be a reservoir for it. We can't hold it. That's toxic for us. It's not good for us, so we have to get rid of it. However, CO2 can't just travel freely through your blood. It's very volatile and reacts with a lot of things. So what we do is we, in our tissues, take CO2 that was generated and we combine it with, we hydrolyze it, so combine it with water using an enzyme carbonic anhydrase to catalyze the reaction, and we convert it into something called bicarbonate. Now, bicarbonate can travel freely, and it will travel up to be expelled through your lungs. So what that does is now you are going to transport that up through your venous system. So the deoxygenated blood and the bicarbonate travel up through your veins. Oxygenated travels down through your arteries. And once we are at the lungs, we actually utilize carbonic anhydrase again, and we convert that bicarbonate back into CO2, And just like oxygen moved through a concentration gradient, now this CO2 is going to do the same thing. So it's going to move from an area of high concentration in this part of our bloodstream by our lungs, and it's going to diffuse across into an area of low concentration, and that is actually what we breathe out when we expel air. So we breathe in O2, it goes through all that cool stuff and all those cool processes, and then we breathe out CO2.